In this video how to make a solar panel charger unit that charges a 24-volt battery, and they are here. I've bought this charger unit of Shottky, Germany, and it worked properly. No complaints about it, only there was a kind of issue that sometimes it started to boost, and in that case the gas barrier of the battery was exceeded, and that meant that the battery started to cook. Strange word, you hear them gassing, and the gas barrier of a 24-volt lead acid battery, we are talking about lead acid batteries here and here, with which I supply a part of my household, and that gas barrier is 28.2 volts. So when the charger exceeds that voltage, you could get damage on the lead acid batteries because of the bubbles. The gas bubbles take out lead particles and give them to the surface, and then they go down into the basis of the lead acid battery, and they form a kind of sludge anyway. And I've done many experiments in the past with lead acid batteries, and you can damage such a lead acid battery within 2 months or 3 months when you exceed the gas barrier. And that's a problem, of course. This is a charger that I made homemade, and that does not exceed the gas barrier. And it's very simple, and I want to show the schematic. It consists of, in fact, one MOSFET. This is the MOSFET that's in charge, that is responsible for the output voltage. And of course we have here one diode to the output and one diode to the input. Perhaps this looks a little bit difficult, so let's look first at the absolute basic circuit, and that's here a MOSFET, drain in, source out. To the gate we have a Zener diode that sets the exact voltage to the output. In fact, it's a series regulator, and that's more or less all to tell. Here that 24-volt battery, lead acid, a fuse, a Shottky diode here, output Shottky diode, input, and we take out a positive voltage here, send it to the gate so that the MOSFET gets into conduction, and the Zener sets the exact output voltage. And it's important to tell that that depends on the MOSFET and the Shottky diodes. Some Shottky diodes have a higher forward voltage, and also there are different forward resistances in that Shottky diode, say from 0.01 ohm up to say 2 ohms or so, and that has an effect. Anyway, it's not very difficult to make this unit. Positive voltage here, the Zener is critical and must be chosen in such a way that the output voltage never exceeds the gas barrier, so between 27.8 and 28 volts. On 28.2 volts the lead acid batteries will start to cook. So here are the Shottky diodes that I've used. But in fact you can use any kind of Shottky diode, and in fact also any kind of MOSFET, as long as that MOSFET can handle the voltage and the current. And this is quite overdone, and this is the circuit that I'm going to test tomorrow. Shottky diode, MOSFET, Zeners are here in a row. In this row there are the Zeners, and here also a Shottky diode. I'm going to test that tomorrow. Perhaps when it's interesting I'm going to publish the results on YouTube. But the circuit that I've showed earlier, and that's this circuit, works very properly. No problems with that. Anyway, so let's go to this part of the schematic. I hope it's visible out of this distance. You see here the Shottky diode. By purpose I've drawn it in this way. Here also that Shottky diode, and here the MOSFET. And the MOSFETs that I used and the Shottky diodes that I used are here. These are the MOSFETs that I used. They work properly. And these are the Shottky diodes. And I salvaged these Shottky diodes out of a computer power supply. So you can find them everywhere. Here for instance a few of them, and also MOSFETs. Solar panel here, maximum 48 volts at 5 or 6 ampere. At first goes into that Shottky diode, then to the regulator unit. The Zener is here, connected between gate and ground, negative, supplied via this 27K resistor, and here the output. Yellow LED to the battery, and a green LED here to show that the solar panel is active. Sometimes you have to make a precision Zener diode that does not go over the gas barrier. And at first you use a few normal Zeners, say 12 volt and 4.7 volts. And with these silicon diodes reversed in a row, you can trim. These are these normal silicon diodes. You can trim the Zener voltage to a very, very exact value, because every silicon diode has a voltage drop between, say, 0.7 and 0.8 volt. So you can add to the Zener row silicon diodes, and with these diodes you can trim the output voltage exactly to the necessary charge voltage, and that is maximum 28 volts, absolute maximum. With 28.2 volts you will hear that the lead acid batteries will give out a lot of gas. That's not good. So, pan over somewhat. Never try to charge nickel cadmium batteries, nickel manganese hydride, and surely not lithium polymer batteries with the help of this circuit. That's a very, very risky circuit, and especially lithium polymer accus batteries can explode. When you use this charger, So don't do that. It's very dangerous. Very dangerous. So flip over somewhat. Here again that basic circuit, absolute basic circuit. And furthermore, it's an interesting and in fact very simple circuit to make. You can find these MOSFETs and these Shottky diodes in old computer power supplies, and then you can reuse them, and that's a good thing for our environment.